Go.
All right, this is a 2014 AP free response question number 4. So right off the bat, it gives you this chart, and I just graphed the points for like a problem, but it says that train A runs back and forth on the east-west section of the railroad track. Train A's velocity, measured in meters per minute, is given by a differentiable function VA of t, which is right here, where t is measured in minutes. And then part A, we have to find the average acceleration of train A over the interval 2 to 8. And since we have the velocity, we need to find the acceleration. So we'll use this equation again, where it's f of b minus f of a over b minus a. So we'll do the points. It's f of 8 minus f of 2 over 8 minus 2, which is negative 120 minus 100 divided by 6. And then we can just simplify that until we get negative 110 divided by 3 meters per second squared, which is the average acceleration of train A over the given interval. And then for part B, we're asked to do the data in the table support the conclusion that train A's velocity is negative 110 meters per minute at some time within t is between 5 and 8. And we can see that at t equals 5, it's 40, and then at t equals 8, it's negative 120. And then we're supposed to say whether that's plausible and why. And we know that from the intermediate value theorem and Rolle's theorem, it is possible because the function is continuous. So at some point, in order to get to negative 120, it must pass negative 100 on the velocity. And then for part C, at time t equals 2, train A's position is 300 meters east of origin station, and the train is moving to the east. Write an expression involving an integral, which is the first part. And since it's 300, it's already 300 meters east, we'll do 300 plus the integral and of the equation, which is b a of t. And then since we have that, it's moving east. And then it says we're supposed to solve using the trapezoidal sums with 3 subintervals indicated by the table. So for this part, we can use a graph over here. So we'll do the first one, since it's from 2 to 8, the first one will be like this. And then the third one will be right here. And then the second one will be something like this, which will give us the equation. And so we'll do 300 plus, and then the area for a trapezoid is 1/2 base 1 plus base 2 times the height. So for the first one, it's 300 plus 1/2 times, it's 40 plus 100, so 140. And then the height is this value right here, which is 3 plus 1/2. And then for this value, it's 40 and negative 120. So for that, we just add them together, and that comes out to be 80, or negative 80 times 3 again, plus 1/2. And then the height for this one is 4, and then it goes from negative 120 to negative 150. So that is negative 270. Yeah, and then so we just this one is a little bit counterintuitive. It's not really what we've learned, but you can also turn it into triangles and try to figure it out that way, just by figuring out the midpoint where it like passes through the line. But travels north from the origin station, and the velocity of train B is given by this equation which they give to you. And at t equals 2, train B is 400 meters north of the station, and we're asked to find the rate in meters per minute at which the distance between train A and train B is changing at a time t equals 2. So we can go over here, and we're given this right triangle, sorry, bad drawing, and it's a right triangle, and train A is going this way at 300, it's already 300 meters that way, and then train B is 400 meters north. So we know that we can find this value using a Pythagorean triple, and it's 500. And then we figure out that we need the equation c squared equals a squared plus b squared, and we do the derivative of this, and it will give us 2c dc over dt equals 2a dA over dt plus 2b dB over dt. And then we can start plugging in the values. So 2 times 500 times dc over dt, which is what we're solving for, equals 2, and then train A is 300 meters, so dA, actually we know that from up here, we know that time equals 2, dA of dt is equal to 100 meters per second. So we multiply that, and then plus 2 times 400. And then we plug the 2 into this equation right here, and it turns out to be, for the value of t equals 2, and then it turns out to be 125 meters per second, so we multiply that over here. And then this gives us 1,000 dc over dt equals 6,000 plus 800 times 125, which we just solved, and then which turns out to be 10,000. And then so it's 6, and then we'll divide by this, so it's 16,000 divided by 1,000. We cross out the zeros. Should be an extra 0 there. And then it turns out to be 160 meters per second for the dc over dt.